So feel free to talk, though. You can ask questions, whatever. Everything will be on, though, so remember that. If you say something stupid, it'll forever be on here. I always try to remember that. All right, so we're going to look at cellular respiration, okay? What is cellular respiration? Basically, it's like cells breathing, okay? Think of it like cells breathing. Cells take in oxygen, and they get rid of CO2. And they do that for a purpose, okay? So they take in oxygen, and they get rid of CO2. Now I wrote oxygen and O2 because that's just the normal gas form you'll see for oxygen. Okay, so they take in oxygen, they get rid of CO2, and why do they do that? Because we have to make energy. Anybody know the form of energy in our body? The main form? ATP. ATP, yep. So we do that in order to make energy. Our form of energy is ATP. Now again, this will be online, so it's good to take notes, but if you feel like you missed something or whatever, it'll be online. You can go back and look at it later. Okay? Now I'm going to clear this page, okay? What do we use? What's the main form of fuel for cellular respiration? What's the main form of fuel our body uses to make energy? Sugar. What specifically? Glucose, yeah. So we use glucose. All right. Glucose is a simple sugar, okay? And in cellular respiration, basically what we're doing is we're splitting. We're going to break glucose down, okay? We are going to break it down. All right, we're going to break glucose down. Okay? And in the process of that, in the process of breaking glucose down, we're going to get ATP. Okay? And we're actually also going to get water. Okay? We're going to get water, which is where oxygen comes into play. Okay? So we're going to break down glucose, we're going to get ATP, which is our form of energy, and we're going to get some water. No. You'll see when we go more in depth. You'll see the water comes in at the very end. That's where oxygen comes into play. Question. We got a long ways to go, so this is just a nice general overview. Okay. All right. Now there is 4, or really 3 main phases of cellular respiration, but there's actually 4. Okay. The first one is glycolysis. Second one is Krebs, but I like to call it citric acid cycle because it actually refers to something. The Krebs doesn't really give you any insight into what's actually going on, but I'll call them both. They're interchangeable. So Krebs, or I'll just abbreviate it CAC. My stylus is having issues here. Okay, so Krebs or CAC. CAC stands for citric acid cycle, and that's because we actually have a molecule called citric acid in that cycle. That's what begins the cycle. So that's why it's helpful. Now, between those 2 phases, we have what we call the intermediate step or transition phase. Okay, intermediate. Oh, this isn't good. I may have to go to my fingers here. Intermediate, okay. Wow, you gotta be kidding me here. All right, so we have glycolysis is the first step, then we have an intermediate or transition step, and then we have Krebs or citric acid cycle. Then we have that didn't work. Then we have our third, okay, which is the electron transport chain. Okay, I just abbreviated ETC. Okay, electron transport chain. That's actually where we make the majority of our ATP. Okay, this is where we make the majority of ATP. Okay, so the majority of our ATP comes from the electron transport chain. So like you'll see in your book where they'll either say 36 or 38 total ATP, right? Well, we're going to be looking at 36, and 32 of those ATP come from the electron transport chain. Okay, that's how much the majority of it is. And in order to get to the electron transport chain, you need oxygen. Okay, you need oxygen for. I'll circle it in blue. Okay, you need oxygen for those two there.
Now,
okay.
Once it's in the transport chain, is it still going to be using oxygen or no?
Yeah, oxygen comes into play at the end, and that's why. And I'll show you. You'll make more sense when we get into it.
All right. No, because the reason I ask is because on my quiz, it asked that same question if it still uses oxygen. And I said yes. And so
I will look at the quiz and see what it says. I'll look at it. Sometimes Canvas changed the answer, or I may have just clicked the wrong answer. So I always review everybody's when I go through the quizzes. All right. So Krebs cycle and ETC, they require oxygen in order to get there. If you don't have oxygen, you'll only perform glycolysis, which we'll look at here in a minute. Okay? All right. Let's look at glycolysis. Glycolysis, easy way to remember to think of glyco like sugar. Glycogen, glyco referring to sugar. Okay? So that refers to sugar. And then lysis refers to what? Splitting, breaking down, yep. So we are splitting sugar in glycolysis. That's what we're doing. What's the sugar we're using? Glucose, right. Okay, so we have glycolysis here. We're going to start with glucose. Now what I'm going to do is make it look like a little molecule here, okay? So we have, each one of these circles represents a carbon, okay? Glucose is a 6-carbon molecule. So I'm going to write 6C here. 6-carbon molecule. That's what glucose is. That's what we start with in glycolysis. All right. In the cell, glycolysis occurs in the cytoplasm. All right, in the cytoplasm of the cell. Okay. So it occurs in the cytoplasm of the cell. I'll write it up here. Cytoplasm. Okay. Occurs in the cytoplasm of the cell. Now we're going to split the sugar. So what do you think is going to happen? We're going to break it in half, right? Someone say that? We're going to break it in half, yeah. Ultimately, at the end of glycolysis, so if we go to the end of glycolysis, because we're not going to get into every step of glycolysis, there's actually about 10 different enzymes that come in during glycolysis and go through this process of breaking down glucose, okay? It's a very intricate, complex pattern, okay? Lots of enzymes, lots of reactions. You're not going to have to know that, okay?
I have to write first.
That's okay. I can use my fingers. Is my handwriting that bad? Is that what you're saying? Well, thank you. Okay, so we're going to break it down from glucose into what we call pyruvate. Okay, pyruvate is a 3-carbon molecule. Okay, so there's going to be 2 of them. So at the end of glycolysis, you're going to be left with 2 pyruvate or pyruvic acid. There's 2 names for them. Okay, you'll see it as both pyruvate or pyruvic acid, and I'll spell that for you. Now, along the way, you're going to have some things happening, okay? Along the way. We're going to, and I'll draw this out in a minute, we're going to use some energy, and we're going to gain some energy. We're also going to go through what we call a redox reaction, which I'll explain in a minute, okay? A redox reaction. All right. Can I clear this page? Actually, I'll just go to the next page. So, we got our glucose up here. It's our 6-carbon molecule. When we break it down, it's going to go through a redox reaction. A redox reaction involves oxidation and reduction. Okay, and those may sound foreign to you, but this is what it means. Oxidation is when you lose electrons. Okay, we're going to tear electrons away from glucose.
Oil ring.
Yes. Yep. Oxidation is loss, reduction is gain. Yep. That's and that is in your textbook if you guys looking for that. That's a good abbreviation to remember for redox reaction, oil rig. So we're going to lose electrons. Now you may ask, where are these electrons coming from? Really what we're doing is we're ripping hydrogen off of glucose. And we're specifically taking the electrons, and then the hydrogens will follow the electrons. Okay? So we're just taking the electrons from the hydrogen, from some hydrogens that are on glucose. All right? Enzymes do this. Okay? These are all enzyme-driven reactions. That's why enzyme chapter is right before this. We're not going to get into all the different enzymes. Okay? So what we're doing is we're ripping hydrogen out. We're taking its electrons. When we take its electrons away from hydrogen, it becomes what? H+. Okay, so you'll see that a lot, all right, in your book. H+ and an electron. So that's what we call oxidation, or being oxidized. Okay, so right there, glucose is oxidized. Okay. Now, where do those electrons and hydrogens go? Anybody know? We have little taxi cabs for the electrons, because we're going to use the electrons and hydrogens later. What?
To the Krebs cycle?
No. They're going to go to the electron transport chain.
Oh, I didn't think we were there yet.
But we have, you were going to answer my other question, I think. We have little taxi cabs or carriers that carry them there. Okay? And what they're called is, we're not going to go into the long name of them, but the abbreviation is NAD+. Okay? So you have this molecule called NAD+. Okay? And what happens is that NAD+ says, I'll take those electrons, I'll take those hydrogens, and carry them to the electron transport chain. Okay? We need those electrons and hydrogens in the electron transport chain in order to make energy. So the NAD+ takes them. So the electrons head there, hydrogen follows. Okay? So then we end up with NADH. Now, the important thing about NADH is NADH will actually take 2 electrons. Each NADH molecule will take 2 electrons, but it'll only take one of the hydrogens. Okay? So you'll see it written like this a lot, right here. You guys may see that in your book, NADH plus H. Because what happens is NADH only takes 1 hydrogen, but the other one kind of follows and lurks. Kind of just hangs out, follows it into the electron transport chain. Okay, but NADH is the only one that, or the 1H is the only one that goes with it. Okay, so that's one of them that we call an electron transport carrier. I mean, an electron carrier. It'll transport it to the electron transport chain. All right. In glycolysis, this happens twice. Okay, so in glycolysis, this happens twice. We end up with 2 of them. We end up with 2 NADHs in glycolysis, and those are important because that's really where we get most of our ATP. When those go to the electron transport chain. Okay? Now, oxidized was losing the electrons. When NADH gains those electrons, we call it reduction, or being reduced. And the reason we call that is because it's reduced in charge. When you gain an electron, you become more negative, right? Because electrons are negative. So it's reducing the charge is what it's referring to. Okay? They gain them together. They come at the same time, but they only really talk about the electrons. The hydrogens follow their electrons.
So the molecule is oxidized.
Yep.
And the NADH plus H plus is reduced.
Yep. Really, NAD plus is reduced. The gaining of the electrons is the reduction. Yep. What we see at the bottom here, this right here, is the reduced state of NAD plus. We would call this molecule reduced because it gained the electrons and hydrogen. Does that make sense? It'll be confusing at first, guys.
Where
Trust me.
is this 6-carbon molecule breaking down into 3?
We're getting there.
Okay. But this happens.
This is
before
in that
breakdown?
process. This is in that process. We're in the process of breaking down glucose into pyruvate. Yep, we're in the process of breaking down glucose into pyruvate. This is just one of the steps. Now we still have our, actually I'll keep it in black here. We still have our glucose here. Now, in order to break bonds, you need what? Energy. Okay. So in the process of breaking down glucose, we actually bring in 2 ATP during the process. So we'll bring in 2 ATP in order to break these bonds. Okay. They occur at different stages, but again, we're not going to get into all those different steps. Okay. They occur at different stages.
36 at the end, right? Is it using 2?
No, that actually comes in at another spot. But we do use 2, so we make 4, but it'll come here in a minute. So we use 2 to break down glucose, okay? Now, along the way, we also, and again, we're not going to get into why, okay? Because you'll have to take a higher level biology course if you want to see that. We're not going to throw that at you today. Along the way of breaking it down into pyruvic acid, we also make 4 ATP, okay? We make 4 ATP. So here on the left side we lose it, and I'm going to show that by doing this. So after I do that, it'll be 2 ADP. And here I'll draw 4. Oops. I'll explain what that means in a minute. 4 ADP. So ATP is adenosine triphosphate, right? So it's an adenosine group with 3 phosphates. Okay, you guys probably seen that in the book or in other lectures. Okay. We have 2 ATP going in. That means we leave with 2 ADP. Because in order to use ATP, what happens is we chop the last phosphate off. And that allows us to use the energy. Okay. So anytime we use ATP, it becomes ADP for the most part. All right. If we make ATP, we just add a phosphate to ADP. Okay, so that's how we made 4 ATP. We brought 4 ADP in and added phosphates to it. Okay, the phosphates came from the original 2 ATP we used, and then it also came from enzymes. Okay, because I know that question will come up. All right. Did you have another question?
I just want to know how we went from 2 to 4. How do we go from 2 ATP to 4 ATP on the other side?
Through the process, we make 4 ATP. Because what happens is, so if I erase this, if I clear this ink, so when I use, let's say I want to break this 3 carbon molecule down, and I bring in ATP, I'm going to get rid of 1 phosphate, and it's going to get added to the end of this molecule. Okay? And so then I'll end up with an ADP, right?
Right.
If I do another one, it'll end up over here. Okay? That's not meant to say poop, but it does. Okay? If you ever want to remember it that way, you can. What also happens, okay, because that actually happens to one of the 3 carbon molecules, enzymes also bring in phosphates during this process, and they do the same thing. Through their reaction, they use phosphorylation and add phosphates. So we end up with 4 phosphates on the molecule. And so what we do is we just...
Enzymes also use the ATP, right?
They create energy in a similar fashion. Yeah. They don't necessarily use... ATP does come into play in some of the reactions, but they also do their own sort of phosphorylation just like ATP does, which is getting rid of that phosphate and creating energy. Okay? So that's how we get the 4 ATP. Okay? So at the end of glycolysis, at the end of breaking down glucose, okay, all you need to know is glycolysis, we break down glucose. Through that process, we get 2 NADH plus H. We do that by taking off electrons, taking off hydrogens. Okay, that's in a redox reaction, right? Oxidation and reduction. Okay, and then we get 4 ATP gross, but how many did we use?
4.
2. We used 2.
I think you said last time you used 4.
No, we gained 4 through the process. So 4 minus 2 is what? 2. All right, so our net ATP is 2. Okay. So really, when we leave glycolysis, we netted 2 ATP because we used 2 to break down glucose. All right, and then at the end we also have 2 pyruvic. If I could spell here. Why did I? There we go. Thank you. My little brain block there. Pyruvic acid. Okay, one of those, the first one's a U. Sorry. 2 pyruvic acid. Okay, so that's glycolysis. Break down glucose, get 2 NADH, 2 ATP, 2 pyruvic acid. All right.